This is PHA 567B, Public Health. In this lecture, we will address the major public health indicators. Um, Previously, in the previous lecture, we talked about the meaning of public health and how is public health a bit different from other clinical sciences. I think the major point we made was that public health addresses the community at large rather than a single person. And we pointed out that there was an evident need for a method to measure the health, quote unquote, of the population. And therefore, there was a need to come up with indicators to evaluate the public health of populations. And therefore, we're going to talk about four major, or in fact, I should say maybe two major indicators, measures of mortality, morbidity, and then we're going to focus a little bit about life expectancy, what is it and how it's calculated. And also we're going to talk about adjusting indicators, namely for age distribution, because you will see a lot of indicators out there that are said to be adjusted for age and sex distribution. So what does it mean? We'll come to that in a bit. So first, we're going to start with mortality. How do we quantify it? How do we measure it? What are the major indicators for mortality? We're going to start basically the mortality rate that are important for public health, things that will give you an idea of how the public health situation in a certain country are things like maternal mortality rates. So that's the proportion of pregnant women dying, probably due to a complication. And they found out that maternal health is is highly correlated with the health situation in general in a country, and therefore we looked at maternal mortality. Another type of mortality rate is disease-specific mortality rates. You pick a certain disease and you try to measure what proportion of people dying from that disease. If you remember the previous lecture, I showed you that the leading cause of death currently is heart disease, whereas in the past maybe 100 or 150 years, it was something else. Also, we can talk about the age-specific mortality rates. Um, so we're gonna come to all of this. Let's start one by one. So the first thing we're going to look at in mortality is crude death rate, and as the name indicate, it's crude meaning that you're not looking at anything specific, you're just looking at death in general. So by definition, this is the number of deaths in a population during a year over the average size of a population. So you're just counting all those that died in a certain population in a certain period of time, and you divide that by the average population size. And this is called the crude death rate. Let me show you in the next slide a distribution of the crude death rate, or a map of a crude death rate in the world. So this is a crude death rate, and the values represented are per 100,000 people. I'm sorry, per 1,000 people. Okay, so when you're reading numbers like 17 to 19 in the map, this is 17 to 19 death per 1,000 people. And you can see this is the highest rate, and you can see it in countries like in the region in South Africa, for example. And this map is a bit old. This is 2009. I have a newer one on the second slide, different color. And you can see starting at 1.5 all the way to 15. Again, this is per 1,000 people. So the lowest death rate, this is again in 2019. So the lowest is 1.5. So the lowest death rate in a certain country is 1.5. So for every 1,000 people, you would see 1.5 dying per year. So think about it. This is for every 2,000, you get 3. So per 100, this is not even 1%. But it can go all the way up to 15 per 1,000. I think it's per 1,000. We'll check later on exactly how to read this. So it can go all the way up to 15 per thousand, and you can look at the map and you can see how the death rate, the crude death rate, is not equally distributed in the world. And I'm gonna mention something now quickly, and we'll come back to it later on. You can notice that for regions maybe in Europe, the colors are darker than north of Africa, the Arab world. This is because of the age distribution. These populations are younger, so people die less because they're younger. We'll come back to that in a minute, and maybe that's a good introduction for the need to adjust for the age distribution. Okay, so this is in general the crude death rate. I have here the crude death rate is, if I'm not mistaken, this should have been Lebanon in the past 50 or so years. So it's starting in 1960 and it's going all the way to 2015. And yes, the country is Lebanon. I'm giving you here a link. I don't know if this link is available any longer, but it's helpful to look at the crude death rate. So you could see that in the 1960, again, per thousand, in Lebanon, we had about 10, 10 per thousand. So that's 1 per 100 dying every year. And over the year, it dropped all the way down to something around maybe 5 per thousand, which is half a percent. That's 2015. You can get to these values from different sources, and you may have different values, but overall, you should get the same thing, nothing quite different. Okay, so crude death rate. It's heavily dependent on the age distribution of the population, as I mentioned uh, a minute ago. The older the population, the higher the crude death rate is going to be. So it's not the best indicator of measuring public health in general. However, it's a good idea to tell you about like how much you predict people are dying. If you use also the birth rate in that country, you can try and figure out the predicted population size over time. So it's not suitable to compare countries when assessing the status of public health in those countries, as I mentioned. Age adjusted death rate is the tool used to compare. Okay, so when you want to compare two countries, you don't look at crude death rate, you look at the age adjusted death rate, and we will talk about that later on. So naturally, what comes second is the age-specific death rate. This is not the age-adjusted. This is just the same idea as crude death rate. However, you're zooming into a specific age group. So it's the number of death among people or person in a given age group divided by the population size in a given age group. Again, here you have a link to WHO that you can click on and see. Um, so more of a formula over there, and here you have an example. Is 37 deaths among New Mexico children age 1 through 14 during the calendar year of 2006, and then you're giving the estimated population in that age group for New Mexico as well, and therefore you can take the number of deaths of that age group divided by the population size of that age group, and then you can calculate something called the age specific death rate for that age group. So 1 to 14 age specific death rate in New Mexico is 9.7 per 100,000 population. So over here we're calculating per 100,000. Okay, so this is an example of something calculated in New Mexico in year 2006. More of the age-specific death rate. This is the age-specific death rate in the US in 2005. And what I'm going to use here is looking at the age-specific death rate for different age groups. And you can see that for those below the year one, and that is typical to calculate the age-specific death rate for those below young, it's because it's a very critical age. So below one, that's age-specific calculated all by itself, and then you have 1 to 4, 5 to 14, etc., all the way to 85. And the distribution we're seeing here is a typical distribution of age-specific death rate, the U shape distribution. It starts a bit higher for those under age of 1. So this age category, children are, or newborn, I should say, maybe are at high risk. And then the risk of death decreases, flattens out, and then picks up as people get older and older, and it goes very high towards the age of 75 and up. Okay, so again, the idea here is to show the U shape. Um, what we're looking at is death rate per 100,000, and this is why you're seeing values like 2,000, 4,000. If you turn it into 1,000, so take out two zeros, you will see a total different values, but the shape will remain. Okay, I think I also have another one right here. So this is the mortality pattern across life span, and this is for male in Costa Rica, 1960. Still is a good example. Even if it's only male, it doesn't matter. You're saying the U or the maybe the J-shaped distribution starts up high, drops down, flattens, and then it picks up towards the older age group, which I think is something that we already expect. Um, Third is infant mortality. So again, if you remember, we're looking at indicators that will give us an idea of the general public health situation in a country. And we started looking at mortality. Crude is the overall, then the age specific is for age groups that are specific to their age. Infant mortality, like maternal mortality, as I mentioned earlier, is one of those indicators that is highly correlated with the health situation in a country. And therefore, people in public health look at it very closely because it gives an idea of the situation. So by definition, infant mortality is the number of children below age of 1. You know, as I showed you previously, those that are below the age of 1 are critical, and they're dying per 1,000 live births. So you're dividing by every 1,000 live births. Because they have a definition of what's the difference between live birth and stillbirth, etc. We're not really interested in the details of the definitions that epidemiologists and public health look at, but we are interested in knowing that this age group is a sensitive and sensible age group, and therefore we have to take it separately. So it's sensible to health related condition, used as indicator for overall population health. Uh, I have few examples here, and I highly encourage you to look at infant mortality for different countries, um, to check what are the values uh, out there. So I have Niger infant mortality is 112 per thousand. So you can imagine for every 1,000 live birth, 100 die. So this is around 10%, which is quite high. And just to give you an idea of the situation in Niger, I'm also reporting the life expectancy, which is about 57 years, which is low. Versus if you look at a country like Iceland, the infant mortality is 2.9 per thousand. Okay, it's much, much lower than what is happening in Niger. And obviously, the life expectancy in Iceland is much higher as well, it's 82 years. So, if you're interested in knowing the infant mortality for Lebanon or for the US or any European country or any Arab country, you look it up. There is one source that I always advise students to look at. This is the CIA book. You can Google it, you'll find it online, and it has all information about different countries. Um, I don't have access to internet right now. This is why I'm not able to show you, but you should be able to find it. You just Google it, and by going to the word book, I think it's called, you can request for a specific country the information, and they have things like crude death rate, infant mortality, etc. And you can look it up, and I advise you to look up the infant mortality rate for our country, for neighboring country, because it gives you an idea of the public health situation. So still we're working with mortality measures. The next one is the disease specific death rate. And here, what you're doing is you're looking at the number of deaths to a specific disease, and you're dividing by the population at risk of this disease. So, what does it mean, population at risk? Most of the time, that's the total population, but sometimes it's not. So, if I want to look, for example, at the prostate cancer specific death rate, uh, on the numerator, I will have the number of men, obviously, since it's prostate cancer, dying due to prostate cancer, and then I would divide by the number, total number of men, not the general population, because women are not at risk of prostate cancer. And ovarian cancer, it would be the other way around. So you just have to remember that you have to divide by the population at risk. Um, in this slide, I have an example of the top 10 causes of death. So you've seen this over and over, and I think, yeah, it's putting back and back the same information. This is the word, so the top 10 causes of death. This is the word, not only U.S. The year is 2015. It's for both sexes and for all age groups. And you can see that the number one ranking is ischemic heart disease, followed by stroke, low respiratory infection, etc. Okay. So I'm going to mention something here right quick because I've said this previously and I would like to say it again. Just notice that we have something called communicable diseases and non-communicable diseases. So the NCD, the non-communicable diseases, another word you may hear is chronic diseases, and the communicable diseases, the infectious diseases. Um, and you can see the differences between them and down at the bottom, the injury. Again, so we're continuing with the disease-specific death rate, and we're doing it by age group as well. So going back to Costa Rica males in 1960, we're looking at cancer mortality pattern across the lifespan. So the number of men happens to be men here dying from cancer, but we're doing it per age group as well. And the nice thing about looking at it this way is you can see that the risk of dying from cancer is really, really low for younger age groups. And it starts picking up at the age maybe of 40, 45, and then it peaks at 70, 75, 80, etc., which is what you would expect to see, right? Whereas if you compare this distribution to the diarrhea mortality pattern across life, again, you can see that it's very high in younger children, especially among infants, and then it flattens out, and then towards the older age groups, it picks up again. So I'm hoping you're appreciating how you can look at these death rate, whether they're disease specific, and then you can you look at them by the age distribution. You have an idea of where the risk is, how the risk is distributed, and then you can compare to other countries, except for crude death rate. Uh, we cannot compare countries, but for the others you can, and it can give you an idea of how the distribution is in your country and other countries, and that can help you set goals of how you want it to be in the coming 50 years. So continuing again with mortality, we have case fatality and proportionate mortality. Case fatality is basically the number of deaths due to specific disease divided by the total number of people with the disease. So when I say case fatality, this is how much this disease is killing among the people that have it. If a disease is highly, I don't know what the word is, like kills, then we're talking about case fatality. I remember at the beginning of the pandemic for COVID-19, they were talking about that anywhere between 2 to 3% of people contracting COVID-19 were dying out of COVID-19. This is case fatality. So COVID-19 is killing 2 to 3% of the people that contract the disease. That's case fatality. Um, and therefore you can compare it to regular influenza to compare and see like what percentage of people that contract influenza die, and I think it was in the below 1 per thousand, something like that. So that's case fatality. Proportionate mortality is the number of people dying due to specific disease. Here we're dividing by the total number of deaths from all diseases. Okay, this is the first time where we're dividing by the number of deaths. So if I say 10% of people dying are dying of of heart disease, what I did is I calculated everybody that died in a specific year. Maybe I have 1 million people dying in a continent in a specific year, and out of the million, 200,000 died of heart disease. So 2,000 divided by 1 million, that would be your proportionate mortality. Okay, so here's an example of the case fatality. And over here you have a list of diseases from very, very high case fatality. So something like plague, something like rabies, smallpox. They used to kill almost everybody that get the disease. And you go down all the way to, for example, influenza, where only less than 1 per 1,000 die from influenza. So that will give you an idea of how of a killer a disease is. And you can compare. So you can look at anthrax, for example. If you inhale anthrax, that's an 85% risk of dying, versus if you eat anthrax, that's a 50% risk of dying, versus there's another one, anthrax. Yeah, if you get it on your skin, that's less of 1% risk of dying, etc. So it gives you an idea of how dangerous a disease is. You have Ebola, etc. Whereas over here, this is the proportionate mortality. And out of everybody dying, I think you have the numbers here, millions, and you're ranking them. So 7.4 million dying out of ischemic heart disease. If you add all the number of dyings and you divide the 7.4 by the total number of dying, you would be calculating the proportionate mortality um, ratio. Okay. So over here, let's see, I think I have some numbers here that are interesting. So this is coming from 2003 United States, and we're looking at the number, the proportion, and ranking of death for leading causes of death. And then they look at it, so this is for everybody, and then they look at it for the age 25 to 44. But we can focus on everybody. So you start with all causes. So 2,443,000 died in 2003 in the US. That's the total number of death. The number that died out of heart disease is 684,000. And therefore, if you take 684,000, you divide it by the 2.4 million, that gets you 28%, which is the proportionate mortality. And obviously, it ranks number one. Okay, so I hope this is a good overview of the measures of mortality. We started off with the crude, then the age specific. We looked at infant mortality because it's very important. I didn't look at maternal mortality, but I advise you to look at it. It's a very important measures of public health. And we looked about case fatality, proportional mortality, disease specific death rates, etc. Next, we're going to start looking at morbidity, measures of diseases. And when you do that, the first thing you have to differentiate when you're looking at disease is the difference between incidence versus prevalence. So what's the difference between the two? Okay, so incidence are new cases, cases that have emerged in a certain population in a specific period of time. So if I start recording the number of COVID-19 contracted at LAU by LAU students starting September 1 all the way to September 30. The incident cases will be the students that newly developed or newly catched COVID-19 from September 1 to September 30. These will be my incident cases. Students that had it before and they still may have it during that period. So somebody caught it maybe on August 28 or August 25, and they still had it by the time the period started. These are not incident. These are considered prevalent. So prevalent cases are cases that were present for all or part of a specific period of time. And here we differentiate between two types of prevalence. We have the period prevalence and a point prevalence. Point prevalence is calculated when the period of time is short, so like 1 day, for example, or 1 week. Period prevalence is when the period of time is longer. So I have an example for tuberculosis in South Africa. You have 600 per 100,000 population. If these are new cases, then they were newly developed in that specific period of time, then these are incident cases. And then the incidence rate would be the 600 over the 100,000 population. Um, versus if these were, they have tuberculosis now, they're not new, then that would be a prevalent case. So more about the incidence and the prevalence. The formula: incidence rate is the new cases of the disease divided by the population at risk of the disease, again, obviously, and it's over a period of time, whereas the prevalence rate are the existing cases of disease divided by the total population and at a given point in time. These are examples of incidence rate for colorectal cancer. So colorectal cancer incidence rate, and they're divided by race and ethnicity and gender. You can look at the top, this is all, and for men versus female, and you can see a 52.7. So the way to read the 52.7, it's 52.7 new cases of colorectal cancer for male among 100,000 men. Okay, um, it's lower for women, and since it's incidence rate, so that we're talking about additional cases. So this year, for every 100,000 men, you would expect to see 52 newly diagnosed. They have it also stratified by race, but you get the idea. Okay. Now I want to point out here, if you look closely, you will see per 100,000 person age adjusted. So again, as I told you, you're going to see many times the term age adjusted, and we're going to talk about that at a later point in the lecture. Here's an example of, again, coronary heart disease incidence rate, if I'm not mistaken. So for the year 2000, 2007, 8, 9, etc., we're looking at the, oh no, I'm sorry, this is prevalence. So the prevalence of coronary heart disease, I think this is the US, year 2000 to 2010. So it's 6.7% in 2006, meaning that in 2006, if you come to a certain community in the US, out of every 100 people, you would expect to see 6.7 that have the disease. Now, these are not new cases. They may had it for years and years, but they still have it, and therefore they're counted part of the prevalence. And as you can see, prevalence is good to track what is happening over time. All right, so incident cases are the new cases that emerges in a defined population during a specific period of time, whereas prevalent cases are cases that were present for all or part of a specific period of time. And again, I make the difference between point prevalence and period prevalence. And to help illustrate the point, I have an example here where we have two dates, January 1 all the way to December 31. So that's a whole year. And you have different scenarios of what is happening. So scenario number one, someone developed the disease and was cured or died. It could be either. The disease is no longer a status in that person before the period started. The second scenario, somebody started having the disease and continued to have the disease when after the period ended. Scenario number three, someone started before, ended during the periods. Scenario number four, someone started during the period, ended after. Five, started and ended during the period. And six, somebody started and ended after the period. And here we ask you the question, who are the incident cases between January 1 and December 31? So the definition of an incident case is somebody, new cases. So if you look between January 1 and December 31, who are the newly developed cases? And the answer is 4 and 5. 4 and 5, both of them developed during that period of time. However, if you're asked about the period prevalent cases between January and December, so if again I'm looking between January and December, but here I want the prevalence. So everyone that had the disease at any point in time during the period is counted. So 2 is counted, 3 is counted, 4 is counted, and 5 is counted. And the last example is the point prevalence on December 31. So if you come to this very specific time period and you ask yourself who had the disease, it's going to just be 2 and 4. Again, this is another example. Same idea. You have different dates: October 1 to 2004 to April 1, 2005, September 30th, 2005. And you have multiple scenarios. The down pointing arrow is the date of onset of the illness. The plus is the date of death, and the up pointing arrow is the date of recovery. And you have 10 different scenarios. And here you can make all kind of questions. So I can ask you between October 1 and April 1, what were the incident, who are the incident cases between that period of time? So you look between these 2 points of time and you start looking for those that started having the disease. So not 1, not 2, not 3. Obviously it's 6, 7, and 10. All three of them are considered incident cases in that period of time. If you want to, however, if I ask you about the period prevalence, meaning the prevalent cases in between these two dates, then anyone that participated, so the 1, the 2, 4, the 5, the 6, the 7, the 8, the 9, and the 10, all of them are considered uh, period prevalence. And if I want to ask, for example, point prevalence on October 1st, those that had the disease on that date, so 1, 2, 4, 5, 8, and 9. Okay, so talking about morbidity, what, what do we learn with morbidity? It's the level of disease in a population. So example for diabetes, when we say that the prevalence rate of diabetes in the UAE is 19.5 versus in Mexico is 10.6, it gives you an idea of how much presence of that disease is. So though it is one of the best indicators of health, it's many times difficult to assess due to the lack of resources to catch the numbers. Um, that takes us to life expectancy. I have I have a video that covers the life expectancy. So I'm not going to go over life expectancy here. You can watch that video um, over alone. Um, anyway, let me talk about it here, and you can see the other video if you want to go over the calculation. So life expectancy, what is it? It's how much a person is expected to live at a certain age. Usually it's at birth, and it's heavily dependent on the age-specific death rate and highly affected by the infant mortality. Um, so basically, so as I mentioned in a previous slide, you can look at life expectancy in a certain country, and you say, well, it's 70 years versus another country, it's 65 years. What does it mean? It means that in that specific year, when the life expectancy was calculated, was in 2021, somebody born in that year, in that country, is expected to live till the age of 80. Obviously, it doesn't mean everybody's going to live that much, and it doesn't mean that no one is going to exceed that number. But this is an overall calculation, and it's based on the measurement that we already discussed, اللي هن age-specific death rates. And I'm going to go over explaining how it's calculated, though in the separate video, you have the details of how this is done. So the way it's done is the following. What you need is you have age categories. Obviously, you start with the infant, which we said is a fragile age, less than 1, and then you start dividing the age groups. So 1 to 4, 5 to 9, all the way up to 85 plus. You may have people doing different categorization of the age group, but this one kind of work. The second thing that you need, which is very important, is you need the age-specific death rate for every age category for that population in that year. Okay, so here we're looking at the US in 1987. We have these age categories over there, and what you're seeing here, the 0.01, so that's about 1%, is the age-specific death rate for those below the age of 1 in the US. Okay, and then you have 0.0002, so it's 2 per thousand. This is the age-specific death rate for those aged between 1 to 4 years in the US in 1987, and etc. Okay, so next to every age category, you have the age-specific death rate for that category. Once you have that, you're done. That's all you need. Next, you're going to imagine that there is 100,000 babies born. So it could be 100,000, it could be 10,000, it could be 1 million. It doesn't matter. You pick the number that you want. In this example, we have 100,000. And what you're going to do is you're going to imagine what's going to happen to these 100,000 babies born in that year. Well, we know that there is a risk of dying within the first year. What is the risk of dying within the first year of life? It's given to us by the number over here. So we know that about 1% of babies die within the first year. And therefore you say, I would expect that out of the 100,000 babies born, 1%, which is about 1,000, to be more specific, 1,008, will die within the first year of age. So how did I get to 1,008? I just multiplied the age-specific death rate, which is called the proportion dying during the interval, by the number born, and I get the number of death. So if the number of death is 1,008, how many survived? Well, 98,992. And I keep repeating the process. So now that they are between the age of 1 to 4, how many will die? Again, I have the answer to that given to me by the age-specific death rate for that age group. So again, you multiply the age-specific death rate by the number, you get the 204, and you keep doing all of that till you reach the end where everybody is going to die. Okay? So now you have three columns. The first column is the age-specific death rate per category, per age group. The second is how many were born. The third, how many are dying. So if 100,000 were born and 1,000 died, how many survived to the second interval? So 98,992 survived to the second interval. During that interval, 204 died. This means how many will survive to the second interval? You just do 98,992 minus those that died, you get the 98,788. So out of the 988,778, those that now reach the age of 5, how many will die within the age of 5 to 9, and so on and so forth till you finish uh, the column. Now comes something a bit tricky. The question is, how many years were lived in that interval? So what you need to think about it is we're no longer thinking about individual, we're thinking about years. So if I have one baby born and that baby lived through the entire period of 1 all the way up to 5, then that baby lived 5 years. If I have two babies born and they lived all the way up to 5 years, then these two babies together lived for 10 years cumulatively together.